This Week in Radio Tech, episode 275, is brought to you by the Axia Soft Service Virtual Console. Soft Service gives you remote control of your Axia Fusion or Element mixing console from home, office, or anywhere. By Zipstream, audio streaming processors and encoders. Choose hardware or software and optional Omnia 9 processing. And by Lavo and the Crystal Clear Virtual Radio Console. Crystal Clear is the console with a multi-touch touchscreen interface. 2 decades of hands-on radio engineering prepared Gary Liebisch for important roles in radio transmitter design and management at Harris Broadcast. Now, he's educating and finding technical solutions for customers at Nautel. Gary talks with Chris Tobin and Kirk Harnack about 4th-generation HD radio gear, plus tight IT integration into today's lower-maintenance transmitters. Hey, welcome into This Week in Radio Tech. I'm Kirk Harnack, your host. Delighted to be here today and glad that you've joined us. This is the show where we talk about radio and RF and audio and digital engineering, everything from the microphone to the light bulb at the top of the tower. And, of course, now we're getting into a different kind of transmitter, and that's internet transmission. So streaming on the internet and just getting your signal out in all kinds of ways. And I've got a feeling there are more technologies coming along soon that will bring additional interactivity between listeners and content creators, whether they're traditional broadcasters or non-broadcast content creators. And we'll try to cover those kind of things here on the show, as well as, keep you up to date now and then on the basics of RF and audio, some how-to shows and stuff like that. This is show number 275, so man, we've done a whole lot of shows and covered a whole lot of ground. And today we're going to cover even more. We'll get to our guest here in just a minute, but first let's go out to New York City and the best-dressed engineer in radio. Yes, here he is from high over the city, overlooking the Papal Parade. It's Chris Tobin. Hey, Chris.
Papal Parade. Oh, I haven't heard that one. That's good. Yeah. No, we have the Pope's arriving. Over 170 diplomats to the UN General Council this week. The skies are clear. The sun is just setting to the west. It's going well. Matter of fact, the Pope arrived at JFK at 5:23. He shook hands, did the press the flesh type of thing, and they were going to whisk him into a motorcade or vehicle to bring him to the helicopter to bring him to Manhattan. He decided he was just going to walk over to the helicopter. You should have seen the look on the faces of the security people. He just turned away from the car. It was the funniest thing because I'm watching the news, the live feed, and I was like, wow, he's not going toward the motorcade. All of them, everybody's like, doors are open, they're all standing there, and he just turns and walks the other way. They've been talking about how he just, they've just talked about how he sometimes will just make changes on the fly. So, if you're a security detail for the Pope, you must be like just nerve-wracking, not knowing what he's going to do next.
Whenever I hear about the Pope and motorcades and vehicles, I always think of that joke. And the punchline is it's the joke with the punchline of, well, sir, I don't know, but the Pope is his chauffeur. Maybe you've heard that.
Yes.
Well, sir, I don't know who's taxi, but the Pope is his chauffeur.
Right.
The Pope was tired of the slow driving, apparently. That's what the deal was in the joke. All right. So, Chris, thanks for the report, and glad you're here. We're going to pepper our guest with questions. And so let's bring him in. My friend and yours, and a great educator and a fabulous engineer and a great salesman, too. It's Gary Liebisch from Nautel. Hey, Gary, welcome in. Glad you're here.
Hi, how are you? Good to see you,
Terrific.
Kirk and Chris.
Yeah. Good to see you. Gary, I want to say the first time I think I just missed you visiting WPTF and WQDR in North Carolina. I visited those guys early in my Telos career, but you weren't there at that time. This would have been about in 2001 or so, 2002 maybe. You'd already.
I was there for 13 years. What took you so long?
I don't know. Telos just hired me, so I didn't have a choice. But I've known you, Gary, as a guy who I have heard you speak a few times, and it feels like I've just gotten educated about AM technology in particular from you, but I know you cover all kinds of subjects. So, well, first of all, welcome to the show, and why don't you kind of give us a little hint as to your background, and then we'll jump into some questions and technologies after our first commercial. So tell us about Gary Liebisch.
Okay. Well, I'm originally from New York City. I live in Ohio now. We're in just outside Columbus, Ohio. Like a lot of engineers, I started out as a top 40 DJ in the 70s. And I had been a ham radio operator in high school. And I found myself in the late 70s at a radio station that had no engineer. and they needed somebody to install an audio console. And I said, hey, I know something. I know Ohm's law, so I know some of the basics of electronics. So I took it upon myself at that station to install the production console, and I just started taking on more and more of the technical responsibilities at the radio station. Cut my teeth on some transmitters that were always down and always breaking down and so forth. So, and then decided that I wanted to be a chief engineer full time at the next job that I went to, which was down at WSPA in Spartanburg. And then had about a 30-year career as a chief engineer in mostly in Raleigh, also in Cincinnati, and then I joined Harris Corporation for about 8 years, and have been with Nautel now for about 8.5 years. So that's the nutshell version, anyway.
Gotcha. And so whenever I go to a show and see the Nautel booth, oftentimes you guys are of course, you're showing off all your transmitters, you're demonstrating various things. You guys tend to have a working transmitter at each booth. And one of the curious things that we saw at the NAB show in Las Vegas last April was this idea of multiplexing a number of stations onto one. I see multiple carriers, but filling up the space of one FM transmission. And I want to hear about that in just a minute. But first, we got to hear from our first sponsor on This Week in Radio Tech. If it weren't for the sponsors, I don't think we could, pay for the bandwidth and the occasional, camera purchase and a microphone purchase now and then. So let me tell you about Axia and a very cool product from Axia. They're one of our sponsors. It's the Axia Soft Surface. This is an audio console. A console control, I should say. It looks like a console, and it runs on a Windows Surface. It runs on a Windows tablet, if you want to. It can also run in Windows on a desktop. It's touchscreen friendly, or friendly enough to where you can touch it and move things up and down. You can turn channels on and off and assign channels. But nearly everything that you could do from an Element or a Fusion surface, you can do with the Axia soft surface. It's a virtual console software, and it gives you the powerful real-time control of your Axia Element or your Fusion mixing console. You can do it from your home, your office, anywhere you have an internet connection available. You can get connected to the mixing engine for that console and take direct remote control of the console. You can pair it up with a physical console, or you can use it instead of a physical console. So there have been some radio stations that they realized, let's say in a production room where they're really just doing a lot of dubbing. They just need different sources on and off here and there and some level control. Instead of purchasing an actual hard surface, they'll purchase the mixing engine as usual, but then they'll purchase the soft surface from Axia. It makes an ideal companion for existing consoles. It's also the perfect audio mixing solution where you have limited space. So you can run it on a PC that's already in the room, in the control room, in the production room, or you can, as I said, run it on a tablet or a Surface type of environment. A lot of possibilities here, and so you want to check that out. I certainly would. Go to the website, go to telosalliance.com, click on the Axia button, and then look for the soft surface. It supports up to 4 show profiles or console snapshots. You can control all 4 program buses and aux mixing buses. It gives you on-screen control of 3-band parametric EQ if you want that. Excellent IFB talkback capabilities. Let the operators talk to other studios or external remote feeds, and full control of the Studio Engine GPIO functions. So that means, if you punch an on or off button on the soft surface, you get the same GPIO control of equipment, of automation systems that you would have from the physical controller. So I'm working hard to think of anything you couldn't do with the soft surface, and maybe there is something, but I'm not thinking of it right now. It's also being on the network via Wi-Fi or wired. It is also NTP capable, so you can keep the clock exactly up to date. You can do your network joins and time exact network breaks if you need to do that. Break away for sports, get back in exactly on time, and things like that. So check it out on the web at axiaaudio.com or telosalliance.com. The product is called the Soft Surface. And I think you're going to like it. A lot of folks do have this, and they like it too. Thanks to Axia for sponsoring This Week in Radio Tech. All right, we're here with Chris Tobin in New York City, high over the Papal Parade, and Gary Liebisch is with us too. Chris, like so many other engineers, sounds like Gary got started the way a lot of us did. Started out as a disc jockey, Maybe we were the only. I was the only one around at a public radio station, and the disc jockey at the time said, "Man, I got a hot day tonight. Would you spin some records for me?" So, yeah, okay, I did, and got interested in electronics about the same time as that too. Chris, does Gary's experience match yours at all early in life?
Yeah, it's pretty much similar. I did a lot of early radio work on the air with, interestingly enough, some of the pirate days, and that was fun stuff. And then I worked at a couple of commercial stations part time, and for some reason, the one of the stations, the program director thought I'd be a good person to have as a talk show co-host for the Tech Talk. Ask the engineer once a month. That was my entree into broadcasting. So
Really? You had a
yeah,
Ask the
it was
Engineer segment?
ask the engineer, and not really talking to the public at my early days in my career. I will say it was an interesting test, and it made me appreciate considerably talk show host of the day. And back then we had Bruce Williams as our evening from TalkNet. So after doing this half-hour stint once a month, I was like, okay, this guy does it 5 days a week for several hours a night. Okay, you know what? It doesn't take a certain type of person to do this. but I will say I did learn something from that experience, and that was I realized how the studio was poorly laid out, and I needed to make some changes for the jocks to work in, and for the guests when they would sit at the side of the table that I was on. So it did pay off. Walk a mile in someone's shoes. And that's what I did.
You're right. We've done whole shows on that subject of studio design and your own experience with observing even some well-known household name talent, and to see, wow, he needs a headphone jack over here, or yeah, I can see how that sight line is a problem. Let's move the cart machines down a little bit or something. So yeah, it's so helpful for the engineer to actually spend time with the talent and see how they can make life better.
Yeah, no, there's a lot of truth to that. And, if you talk to folks in industrial design in the early days, I had a chance. I worked with a friend of mine. He got a job at Grumman and was working on the Tomcats, was the F-14, I think it was, out of Bethpage, New York. And I was talking to him about the work he did and the designs and how they did stuff. And he would explain to me what they go through to get to a certain design in a cockpit or of anything on the plane. And I sat there going, well, that's interesting. So you actually sit with the pilot, you throw them in a simulator, or you throw them in something that looks like a simulator, and you say, have at it and tell us what you don't like, and you get prepared for the very, very negative response. He goes, absolutely. More negative, the more fun we had. I was like, wow. So I took the same thinking in the broadcast studio, and I said, all right, let me talk to the program director, let me talk to the jocks or the announcers and say, what don't you like about the studio? And let me tell you, the response I got from folks after they realized I was serious and not just kidding with them, and I actually made changes after they made suggestions, it's paid off handsomely. And I really recommend folks to do that today, even if you're in the IT world. In IT applications, understanding how a computer is used by an end user is key, and the layout of the desk or studio itself.
Gary, your work at the stations we mentioned earlier, WPTF and QDR and also WKIX, these are call letters that are familiar to me just because they're well-known stations. In fact, one of the things I know your station's from was there was an EAS training video that was done, I guess, at PTF and QDR. Those call letters came up quite a bit. But I wanted to ask you, Gary, what parallel experience did you have in terms of watching talent and figuring how you could help them do their job better as their engineer?
Well, when I made my first transition to being just a chief engineer at a station, as opposed to being on the air, it was made known to the staff there that I had been on the air before, and they really loved that. I mean, they felt that the engineer that I was replacing was a retired guy, kind of from the old school, and he's kind of like the guy that whenever an on-air talent complained about something, he would just kind of grunt at them, and say, "Oh, those DJs," And but I came in, I was fairly young at the time, and they said, "Wow, you've been on the air," and then they even let me do fill-in periodically, and so yeah, the ergonomics really works into it. If you've been there and done that, and you know how important at that time, something simple like a count-up timer is. Count-up timers were relatively new back then, and how important it is to have everything within reach, and so I found that to be, my experience on the air was invaluable in the succeeding years where I found myself having to design studios, for good on-air ergonomics.
Well, then after this your stint at 13 years, long stint at those stations, you became pretty well known, and you took a job, I believe, with Harris. Is that right?
Yeah, I was working in Cincinnati at the time.
Ah,
I had moved after Raleigh. I had been there for 13 years, and Jeff Littlejohn hired me to be the market engineer in Cincinnati because it was Chancellor Broadcasting at the time,
oh
on
yeah.
4 stations in Cincinnati, and he was moving to the corporate position there and needed somebody to replace him as the market engineer in Cincinnati. So I took that job and moved to Cincinnati. And so I was there for a couple of years. In fact, while I was there, Harris announced that they were opening a plant locally in Mason, Ohio, and I thought, gee, that'd be a great place to work and get away from the pager and so forth, and get on the vendor side of things. And so after just a couple of years being a market engineer in Cincinnati, I went to work for Harris. Initially, it was when they bought Jack Williams out for Pacific Recorders
Oh yeah.
in about 1998. And then subsequently, they started tooling up for the big push for HD radio, and I was more interested in the RF side, so I moved over to the product development side of transmitters in around 2000, and the HD radio rollout started about a year or two after that. So.
I'd love to hear about your work in informing or being part of product development at Harris. Is that something that you can tell us, relate any stories about, or any features or comments from customers that you
Yeah,
brought
sure.
to the mix?
There's so much more that goes into product development that the end user really doesn't really know about or see. It's a fairly rigid and long process. From start to finish, it's about an 18-month process to develop a product, and you probably know this from Telos as well. There's a lot of time spent on paper before even the first screwdriver or solder joint is put together, and you pretty much have to know with a documented plan exactly what you're going to do before you get started. And then there are various stages that you go through that have to pass approval by different departments, and of course there's a lot of documentation, and everybody has to know what everyone else is doing, and most importantly, you have to stay on schedule. You can't have distractions that are going to throw. Make an extensive use of things like Microsoft Project and Gantt charts and so forth, respect to when a product is going to be released. And even then, of course, the products are very often late, even with that kind of planning. There's design and specifications, and I would be there would be a product line department that was kind of the interface between sales and engineering. In other words, sales might have a concept of what they need as a product in the marketplace, and it was up to product line or my department, or perhaps as the project lead on a particular product, to come up with the specifications and what features. And cost control is a big part of it too, because there's always a cost target. We want to sell this product at a particular price, and in order to do that, it has to come in under some certain cost target. So every element of that cost, and not only the cost of components and assemblies, but the cost of assembling them, and the cost of testing them, and the cost of repairing them, all those costs have to get built into the plan as well. And on a monthly basis, you'd have to report back on where you are in meeting your targets. And hopefully, about 18 months later, or 2 years in some cases, a product comes out the other end. And such was the case. I was heavily involved in the development of the FlexStar Exciter when that was released in 2005, and a few other transmitter products during that period as well.
Wow. All right. Hey, Chris, feel welcome to jump in. The stations that I have worked at haven't had too many later model Harris products. So, Chris, if you've got questions or comments about any particular ones that happened in the early and mid 2000s, please jump in.
The ones I worked with was the Vistamax and the later DX series transmitters. So that's the stuff I was working on, and the early MW1As. That was a classic.
Yeah.
There's a story that I guess I can relate. I may have related it before. During one of the ham conventions in Dayton, Ohio, I got a chance to, with a bunch of other hams, to go to the WLW transmitter site north of Cincinnati. Is that in Mason, Ohio? Is that where that
Yeah,
is?
yeah, I was there last week. They had a great SPE meeting from Cincinnati, and they did a presentation. Jay Adrick from Harris, now Gates Air, did a great presentation on the history of WLW from start to finish, and he had 195 slides to show.
Oh my
Many,
goodness.
many of them going back, 60, 70 years, and it was an excellent presentation. He had everybody mesmerized for 2 hours.
Well, my story was I was pretty impressed with the diligence of the Harris engineers. This would have been back, I guess, in the mid 2000s, and there, I guess the 50 kilowatt transmitter that was out at the time. Which one was that? Was it a DX?
3DX50.
DX50. Okay.
3DX50.
And it seems that they had some customers with higher frequencies, higher dial positions, maybe something over 1 megahertz. And they had some issues in the field, and they were trying to reproduce the issues and solve them. And so the folks at WLW had a great platform there, and they had a DX50 there. And anyway, apparently what the deal was that WLW would switch to a different transmitter late at night, and because they got like 5 of them there, and the Harris engineers would come in and use the WLW's DX50 and put it into a dummy load, and they would tune it to a frequency of interest, trying to reproduce the problem they had been seeing. And the reason the story got related to me during a tour of the LW transmitter site was there was a piece of paper in a trash can. It was the paper was laying face up. Anybody could look at the trash can and see it. And the paper said in big block letters, "Remember to put transmitter back on 700 before returning to air."
Right.
So,
Well,
okay, on the one hand, it's a funny story. On the other hand, it shows you the diligence of the engineers trying to reproduce the problem, as much as possible, like another customer had seen it in the field.
Well, the very first prototype 3DX50 was at WLW. It was just very convenient because they were in Mason and the Harris plant was in Mason, and typically during product development, you want to take the first unit and put it in the hands of somebody who can give you some good feedback. So the very first unit went to WLW, and yes, initially they put it on part time, and then ultimately later on they put it on full time. Actually, that transmitter eventually was replaced with a production unit so that it would be up to speed with everything else that was being manufactured in the mainstream years later. In fact, that very first unit doesn't even exist anymore, I don't believe. But yes, during it would just put it around 2000, 2001 was when that very first unit was in there undergoing some tests, and that could have been the period that you were talking about. Yeah.
Oh yeah, it may have been a bit earlier. Yeah, sure, may have been. So okay, let's move on to some of the things that you and I talked about before earlier this week. Advances in HD radio, because now you're with the Nautel team, and Nautel is certainly recognized as a leader in transmission technology, and helping to bring the latest advances in efficiency, amplitude modulation, FM amplification, and HD radio, and DRM, other digital radio designs to bear. I don't know what you want to talk about first. Advances in HD radio. Do you want to hit on this interesting and a really intriguing subject of multiplexing a number of stations onto the same HD, getting rid, I guess, of the analog altogether, all HD, and what you can do with that if you want to?
Well, first, a little bit of background on our delving into HD radio. We certainly make no claim to being first there because, frankly, Nautel was rather late to the party with respect to HD radio. And when it began to be rolled out in 2001, 2003 era, our FM transmitters were not really ready or designed to be able to handle digital. So we got into it a little bit heavier around 2005 or so, when the generation that handles importers, that utilizes importers and exporters, became widely used. But really, it really wasn't until about 2009, with our NV transmitters, that we really started moving ahead on the technology. You know, we all had a recession. Everybody remembers, in about 2008. And we found ourselves in a situation where we were being extremely aggressive on product development. Some of the other companies were kind of cutting back, understandably, because of the state of the economy. We were moving ahead with some very heavy product development and a very significantly sized development team, and some very brilliant people in that department as well. And we came up with a few unique solutions and some things that nobody else was doing. Not only did we come out from an analog standpoint with the very first 40 kilowatt solid state FM transmitter, but on the HD radio side, we were doing some things that nobody else did. For example, we have a brilliant research engineer named Philip Schmidt. And anybody who's been to trade shows, he's delivered a lot of papers, and he's done a lot of great things for us. But he had something called reliable HD transport, because one of the issues that was occurring back then was there was diversity delay drift, which has become the subject of a lot of articles recently. But and there was packets being dropped, and he developed a protocol, an encapsulation protocol called reliable HD transport, that nobody else was doing, to make that E to X stream a bit more reliable. A few years later, he developed what we've come to know as power boost, which is a peak to average power reduction technique that we now build into our transmitters. So we've always tried to differentiate ourselves from what everybody else is doing on the HD front, with some very unique and interesting development. And this HD multicast that you spoke of, that we demonstrated at NAB, is the latest of those. And this is not a product, so this is a technology demonstration, and we came to show it to everybody, to say, here's something that we can do today, and here's how it works. Do you, the buyer of these products, or the implementers of HD radio, see any use for this in the marketplace? So we don't have a product to sell; it's a technology demonstration. And essentially, what he did is he has leveraged some of the new flexibility that Ubiquiti has put in release 4 of the Ubiquiti code, which is being released now. And we wanted to do some interesting and different things to differentiate us from some of the other products. And he came up with a way to stack up to 15 multicast signals across 3 FM channels, each 100 kilohertz apart, not 200 kilohertz, but 100 kilohertz. So, for example, 98.1, 98.2, 98.3. He uses one X-Gen system to do this, 3 importers, 3 exporters. And by spacing these 100 kilohertz apart, he was able to aggregate about 123, about 123 kilobits from each of those signals to get about 370 kilobits aggregated. And then he's able to basically take as many as, depending on the bandwidth of each channel, as many as 15 signals. Now, the first reaction a lot of people might have is, why do we need 15 channels on an HD signal? People can't even figure out now what to do with HD2 and HD3. But it has some other implications, particularly internationally. For example, we've heard from some countries where they just don't have any more FM channels, and if you can come up with a way to put more streams on the air, they're interested. I took one take, and when I do SPE presentations on this topic, I diverge from what some of the others in the company do when they present on this topic. And I took the market that I live in is Columbus, Ohio, and I showed in my presentation how you could take the Columbus, Ohio market, and through restacking of the FM signals, you could not only reduce the population in the band, the number of RF signals, but you could also have plenty of room left over to put AMs. And obviously there's a lot of re-regulation associated with this. There's existing legacy broadcasters who would have to buy into it. We're simply saying here's a technology that, along with all the other technologies that are out there, and everyone's talking every day about, where can you fit in translators and low power FMs, and where can you put the AMs, and this is just one other solution that may or may not go anywhere, but we're saying here, you can do this today, you can do it in the existing FM band, without any additional spectrum, and you can do it with existing receivers, because we demonstrated at the NAB in the spring. Philip did this with stock existing receivers. The only stipulation being that he had to go into the back door of them to make sure that they could tune 100 kilohertz apart, like 98.1, 98.2, 98.3, and that was just a very minor thing. But he was actually able to scan from 1 to 15 and demonstrate that you could do 15 different channels. So in a nutshell, that's it. So in a couple of weeks down at the IEEE Broadcast Symposium in Orlando, Philip is giving the paper again. He's rewritten it and refined it, and if you're not going to be at the IEEE, which most people are not, there's a webinar that we did a couple of months ago that explains the technology, and it's on www.nautel.com/webinars, and it explains the whole HD multicast concept in about a 30-minute webinar that Philip did with Chuck Kelly. So it's a conversation starter. It's not a product that we're selling. There are people out there. There are different entities, I should say, that are interested in exploring the technology with us to see if it has an application, in this country or elsewhere around the world.
I think it's a great idea. And again, I'm having a little trouble thinking, okay, how would I put that to use? Hey, with my stations in Greenville, Mississippi, I guess and there are no HDs in a little market like mine, or in our little market, but we keep hearing is how there's more and more HD radios out there in cars. A lot of folks may not even realize they have it if they live in Greenville, Mississippi. But it'll be interesting when we really feel like there's enough, and our little group of stations could do this kind of thing. Somehow get 3 channels together. Again, it's just a thought starter, and I agree with you. It could be good for countries where they maybe do have real control over where their stations are allocated and spaced out, and then go all digital that way. It's pretty intriguing. Chris, you got any ideas for what you do with 15 audio channels?
You can come up with programming for it, but I think the key is you need receivers for people to enjoy it with. So I think you're right, Kirk, about the more people know there's a product available, the more it becomes available, greater chance of moving in that direction.
Hey, Kirk,
yeah.
One of the concepts here, in the way that when I do my band scheme, so to speak, my hypothetical band scheme for Columbus, is that I took the non-com band from 88 to 92, where I think in Columbus there are like 11 or 12 signals, and I restacked them onto 3 channels. So that means a lot of channels get vacated. And I took the 3 best non-com facilities on which to put these, and in essence, a number of those signals become nothing more than tenants on the landlord signal, so to speak. In other words, they're really not licensees anymore. They become tenants. They become one of the multicast channels. So you're really not faced necessarily with having to come up with programming for 15 channels. You have to stop thinking like a conventional broadcaster, and think more like, okay, here's the landlord station, and maybe they get a little bit more data bandwidth, or they get as much as they want, and then the tenants can pay based on their lease. They can pay for bandwidth, they can pay for injection, they can pay for number of channels, and they can all negotiate all of that, and they can get whatever they want, within the realm of negotiation. And then once you get all done with that, in my example, there are channels left over. And then you can figure out, well, what can we do with these other? Who else wants a channel? Who else wants to lease a channel? So it's kind of endless possibilities. But I understand it is very much it's a cloud. It's up there in the cloud now
Yeah.
for us to come up with applications and uses for.
I can see it now, where every small town in Texas will be able to have their high school football game on a different channel. Every game will be covered. Indeed. Hey, folks, you are watching or listening to This Week in Radio Tech, episode 275. Kirk Harnack here, along with Chris Tobin in New York. And Gary Liebisch is with us, talking about advanced digital communications. And we have more topics about HD and other RF items to come up. So thanks for tuning in and watching. Our show will continue. We're going to hear now from my friends at Telos and the Telos technologies that produce audio processing and audio encoding for streaming. So I'm having to say that in kind of a large way, because it used to be that Telos had one product to do audio streaming with, right? Well, you got to think of the internet as another medium onto which you can put a transmitter, if you will, and hit more and more listeners. And we're finding that streaming is now hitting between a third and half of people in the U.S. Every week. So, and if you look at every month, it's well over half. And more millennials, for example, are not tuning in to traditional AM or FM broadcasting, but they're tuning in to the web, to apps, to things like Pandora, iHeart, and RDO, and all kinds of other apps like that. So you want to get your radio station, your cluster of stations on the web. You want to get the content that you're producing. Maybe you're not a radio station. You just want to get out there on the web, like this podcast is from the GFQ network. You're going to need a way to, first of all, do audio processing that's appropriate for the web to get the most out of the psychoacoustic encoders that are used, typically MP3 or AAC. And then you want to have an encoder that's of high quality, there's no degradation in your audio quality. And maybe you want to be able to produce audio streams at different bit rates. Maybe you even want to do multi-rate streaming, which is going to be the next thing coming along. I'm already doing that at one of my stations as a demo. And so we're using Apple's HLS, or HTTP live streaming. Well, the good news is that some of the Telos products now already do that. So if you go to the Telos Alliance website and click on a link for processing and encoding for streaming audio, you're going to be a little bit amazed. It now fills up the screen here as to how many different products we have at Telos that do audio processing plus streaming. There's the ZipStream X2. That's software that runs in a Windows environment, and you buy licenses for the number of inputs, and for each input you can do more than one stream. You can do streams at different bit rates, and you can run different audio processors. There's the ZipStream 9X2, which adds Omnia 9 style audio processing to the ZipStream X2. Now, the X2 comes with our standard 3-band processor. I love it. Sounds great for most things. But if you really want to be out there and have the ultimate audio processing, well, Leif Clayson's Omnia 9 processing is available too. So the ZipStream 9X2. But there are other products too. The ZipStream R1. Now, that's the box formerly known as the ProStream, like the one behind me right over here. The ZipStream R1 is a 1-rack unit box, takes one audio input and produces as many as 2 different kinds of streams, and sends to several locations. There's the ZipStream R2, brand new product, just introduced at IBC a couple weeks ago, and it can take in up to 8 audio programs, and it's also available with Omnia 9 processing as an add-on. So it can produce 8. More than 8 streams, actually, 8 programs coming into a 1-rack unit box. So it's an appliance that does all the streaming. Then there are other products like the ZipStream S4. This is a PCI card. It's PCIe card, actually, that does all the audio and streaming inside a computer. And it's really only using the computer for power if you run audio in externally. So it's not dependent upon the operating system of the computer to create your streams. Bottom line is it boots up in 15 seconds and it's producing streams for you. There's also there's the ZipStream S4. There's also there's other products, the ZipStream AXE and ZipStream FXE. The AXE, our first original basic stream encoder, and the ZipStream FXE. This is really interesting for podcasters. It's a file-based audio processor, so you can just drag a file into ZipStream FXE and process that file and have a processed file ready to stream for your podcast or on-demand listeners. So a whole range of products now, all using fully licensed Fraunhofer reference code for the encoding, and just a variety of options, including metadata. That's built into all these products where you can add the appropriate metadata to show up on your listener's screen. So check it out if you would. Go to tellusalliance.com. Processing and encoding for streaming audio, and as we say so often here, stream like you mean it, because that's your next transmitter right there, added on to the transmitters we're talking about. Thanks, Telos, for sponsoring This Week in Radio Tech. Okay, we're here with Chris Tobin in New York. Chris, you still there with us?
Absolutely. Just the noise you may hear behind me is the NYPD helicopters flying overhead. I've just found out the Pope is on his way down Fifth Avenue toward St. Patrick's Cathedral for the 6:45 services. So things are on a move.
Wow. Well, do you need to break in for any breaking news there?
No, I'm fine. I'm working with a couple of people tonight and tomorrow night. They're covering the papal visit at the UN, so I'm going to be very busy for the next 48 hours.
Ah, yeah, Gary.
I have an idea. Everybody wants to know where the Pope is at every given moment. Apple could come out with an app, and they call it "Find My iPope."
Or just like iPope. Yeah. Oh, gee, that's a great idea. I wonder what the Pope uses for streaming. You know, Vatican Radio is legendary, and I bet they do streaming nowadays. You know, I know Vatican Radio has some Omnia audio processors because Frank Foti went there. I don't know if he got to meet the Pope, but he got to meet the radio guys. So, Gary, let's move along here. You know, you were telling me how transmitters are getting smarter nowadays, and that it's getting to the point where, well, I'd like you to tell the story about how IT guys are actually now. Transmitters are coming this way, IT guys are going that way, and they're meeting in the middle where IT guys may be able to take care of the transmitters, especially when all the RF guys retire. Where's that headed?
That's right. It's all going in that direction, and what's happening? It's all aimed at allowing engineers to do more with less. To be able to accomplish more. Engineers have more stations to take care of. There are fewer engineers to do it. If you can resolve a problem without making that 1-hour trip out to the transmitter site, or at least know what's going on out there, be more informed about what's going on at the site, then that enables you to do your job better and enables you to do more with less time. So along those lines, yes, transmitters are now getting smarter. And are able to diagnose themselves. And, we introduced that in 2008, 2009 with the NV. And, the generic name for a graphical user interface, a GUI, we call ours an AUI, or an advanced user interface. And we introduced that on a couple of the AMs and in all the FMs in 2009. Granted, in 2009 and even today, there are not probably even the majority of transmitter sites that have internet connectivity. But boy, if you do have internet connectivity, what you can do with this AUI in terms of having connectivity, what I always would tell customers is anything you can do in front of the transmitter, short of physically pulling out a module, you can do remotely, through the AUI in terms of all of you remember years ago, we would go through and we'd do a weekly transmitter inspection, and you'd go and you'd switch through all the multimeter positions to read all the meters that you can't normally read from the studio, and you'd log them down typically. And I used to do that religiously and save all those logs, and then I could spot trends if things were going south on me. Well, all of that can in essence be done now remotely. You don't have to go to the transmitter to do that kind of thing. And yeah, the story I told the other day was about how how we were selling, I think, five engineers, excuse me, five transmitters to a station in upstate New York. It was a non-com group, and there was a new young IT guy, and he was intrigued by our use of the AUI and the user interface and so forth. And there was an older engineer who was in the process of retiring. And the IT guy took such a liking to the transmitters that they basically passed the baton from the older engineer to the younger IT guy during the process of buying those transmitters. Because when you think about it now, with today's modern solid state transmitters, and this is true of our competitors as well as ours, I'm just talking really now about a trend in the industry. When you go solid state up at high power, you're talking about, well, no more high voltage. There's no more soldering for the most part. There's no tuning required. There are very few, if any, single points of failure. And the diagnostics is done through a web interface. So the IT guys say, I've got nothing to fear anymore. I can handle this. You might have to teach them the difference between copper and brass on the antenna, and you might have to teach them what 50 ohms means and what VISWAR means. But the point is that it's a lot easier for the IT guys to move into this. And we're finding that as we sell more and more of these transmitters into stations that are in this process of passing the torch from the guy who's been there for 30 years to the younger guy, that the younger guy, who very often has come in through IT, feels very comfortable with our transmitters, and the fact that he can now maintain five of them all at different sites allows him to do more, again, with less time. And that's where the industry is going now. And of course, the reliability has gone up significantly. I always like to tell the story. You mentioned the fact that I spent some time at WPTF. One of the fascinating things it's one of those old 50 kilowatt AM sites that had a lot of history. And I would go in there, and there was so much had been preserved there that I'd go in there and I'd look at maintenance logs. I remember a bound book that they had there, which was the maintenance logs from 1944 during World War II, and they had all 1 year in one volume. And you could randomly open up this book to any given page, and on any given day, the activity that occurred at that site easily filled 2 pages. And there were probably 4 engineers doing all that work. And yes, they were all wearing ties as well. But the point is that, transmitters were much less reliable back then. I think stations measured reliability then in hours. Uptime was probably measured in hours and perhaps days, whereas now we measure uptime in months and years. And so we've come a long way since 1944, and it takes looking at some historical documents like that to realize how far we've come and how much one guy does now compared to what 4 or 5 or more guys did back then.
Wow. I on the one hand, my emotion tells me, I don't want to believe that the IT guy can take care of the transmitter. That was always, something that I needed to do. I need to be at the transmitter site. And there are still physical things about the transmitter site that either an RF guy is going to have to do or the IT guy is going to have to learn. But you know what? You're right. At a couple of my owned transmitter sites, and we got small radio stations in Mississippi, but at the couple of them where I've got a Nautel transmitter and a Nautel exciter, I have remote control and remote monitoring that is just amazing. And I can see that I can see your point where this is where the equipment at a transmitter site can become more and more if you will, a computer that transmits, and an
RF server, we'll call it.
Yeah, a server. Yeah, an RF server. And you're right with the solid state technology and the lower voltages. In fact, let me ask you about voltages, because it seems like in some older Nautel transmitters that I took care of, there were still some voltages. I mean, not high like tube plate voltages, but there were still voltages in the neighborhood of 175 or 200 volts. And has that changed now? Is it now lower than that?
They are at that level in AM transmitters still,
Okay.
and because the fact that they're amplitude modulated, so you have to have the dynamic range of voltage to amplitude modulate a higher power transmitter. But in the FM transmitters, typically I mean, you certainly can see AC voltages in an FM in any transmitter of certainly 240 volts. That goes without saying. But once it gets converted to DC, everything you're seeing, everything, for example, in our FM transmitters now works off of a 48-volt bus. Everything is converted to 48 volts. There's not even 120 volts AC in the exciter. It's working off the 48-volt bus as well. So it's all pretty safe in low voltages now.
Yeah, choosing 48 volts, such an industry standard, one reason is because that qualifies as low voltage in many jurisdictions, and may not require certain inspections or certain qualifications to take care of it. Was choosing 48 volts, did that factor into it, or is it just a matter of convenience where we can get enough power and enough, and the current's not too high at 48 volts? What plays into that decision?
A lot of it has to do with what's available with respect to commercially available switch mode power supplies. For example, the switch mode power supplies that we use, we had a lot of input to their design, but a lot of them are to a large extent off the shelf commercial or industrial platinum class switch mode power supplies that might be used in other communication industries. And by using a standardized 48 volts, that allows us, that's one less thing that we have to invent and design when the wheel there has already been invented in that case.
Yeah. Chris, there's a question that I think you had about some advanced features.
Well, we were talking, Gary, you were talking about earlier, the ability to service. It's easy, the web and everything else, and the knowledge base is so much improved with the solid state. Talk about the service? What is it called? Phone home, I believe it is. Right? Is that correct?
Yeah, sure, yeah. Well, what happened? An interesting thing happened after we implemented the AUI. We had a install tech from Nautel out on the West Coast, and he was installing a 50 kilowatt AM. I think it was for Crawford Broadcasting, and he installed a 50 kilowatt AM transmitter, and he headed. It was, I think, a long holiday weekend, and he headed back home, back to Halifax, and since it had the AUI and it was connected to the internet, he wanted to check in on the transmitter as soon as he got back home. Well, he gets back home and checked in, and he noted that there was an infant mortality in I think it was a power supply, a low voltage power supply or something. So it was a holiday weekend, and so it did not affect the operation of the transmitter at all because it had redundant power supplies. So he went through whatever he had to do in order to get a power supply out to that station. And Monday morning, he calls up the engineer and he says, when I got back, I noticed that you had a failed power supply. There's already one on the way out to you. You'll get it tomorrow. And we started to get to thinking, how can we leverage this ability in service, about our ability to do kind of proactive service for customers. And that's where the concept of phone home was born. And it probably went under at least a couple of years or more of development, and we had beta sites and so forth. But what it ended up doing is it's an active program now that we don't charge any extra for, and it's purely voluntary. And a station can voluntarily participate, and Nautel does trend logging back at the factory of all the critical parameters in a particular station's operation, and it measures any events that occur. An event not necessarily being just an alarm, but any on-off or even routine events get logged. And we look at those trend logs, and if we see something, it's not meant as a real-time notification for, hey, you're off the air, did you know it? It's meant more as we've noticed for the last 3 or 4 days that this alarm is showing or this fault has occurred. Are you aware of it? Because the degree of monitoring that stations do from one station to another varies significantly, particularly if they happen to have contract engineers. So it's kind of a proactive kind of a service thing. Now, it's not really a firewall risk. Some people might think, wow, Nautel's getting into my transmitter. But because of the way the system is designed, it is only sending data out. It uses SNMP protocol to just send data out. In order to allow ingress from Nautel, a customer actually has to go into the transmitter, and that can be useful as well, because you might, for example, call in a trouble report to Nautel, and very often you'll get the service administrator arranged to have someone call you back, and it's conceivable that the technician could check the trend log and call you back, and he might have a diagnosis for what's wrong with your transmitter before you even open your mouth. If he's seen anything in the trend log. So we have this huge map that we usually demonstrate at shows like at NAB Radio next week, and we have a big map that shows, and all the participating stations are shown on the map, and of course it'll have green dots where everything is fine. It might have a yellow dot that indicates the transmitter's on the air, but it's showing some type of fault, or it might show gray if it's offline. But it's been received very well. I mean, we've got so far it's only in the U.S. that we're doing this, but there are several hundreds of stations participating in Nautel Phone Home. So it's worked out very well for us.
That sounds pretty amazing. And let me ask you, Gary, I'm looking at actually one of my transmitters right now. It's a 2.5 kilowatt VS series. We've got it doing 2.65 kilowatts because we need to get everything we can out of it.
That's okay.
And I'm wondering, now it doesn't have any built-in history logging, right? That has to be done externally, right?
It does. All of our transmitters will do what's called event logging, which means that if anything changes state or any alarm is generated, and it'll retain those event logs. It can handle thousands of events. It can retain them. Now, what we do not do yet at this point in time is regular parameter meter readings. Now, if a parameter goes out of tolerance, it'll certainly measure that. For example, if the heat sink temperature gets higher than it's supposed to be, or an air filter gets clogged to the point where something gets hotter, or a current goes too high. If things are out of tolerance, it will log that as an event. But it's not doing parameter logging in the sense that the way people would log PA voltage and PA current and power output every 3 hours or whatever. We're not doing that currently. But it's but you can, with the exhaustiveness of what it is monitoring, you can pretty well be confident that if you're not getting any alerts or alarms, and it can send emails out to you as well. But if you're not getting any of those type of alerts, everything's copacetic,
Wow, cool. Hey, we are to the point we're running out of time. We're going to take one more break, and when we come back, Gary, oftentimes we do a little tip of the week. So if you have an engineering tip that you can think of in the next couple of minutes, that would be awesome. Something you'd like to tidbit you'd like to pass along to our listeners and viewers, that would be great. Our show, This Week in Radio Tech, is brought to you in part by our friends at Lavo, Lawo, Lavo.com. And they're the makers of a lot of audio consoles, but a lot of them are networked audio consoles. They're doing the Ravenna standard, which includes compatibility with AES-67. Well, you want to hear about the Crystal Clear console. Crystal Clear console is pretty interesting. It's a rack mount device. That's the inputs and outputs, whether it's analog in and out like microphones and other analog inputs, analog outputs, some AES inputs and outputs, and of course, Ravenna AES-67 audio over IP inputs and outputs. That's a one rack unit device that can go anywhere that's convenient, typically in the studio or the rack room. Then the actual console itself is a control surface made from a PC with a multi-touch touchscreen monitor. And the application that runs is full screen. It looks like the whole screen is the console. And it's a beautifully designed application that looks like a Lavo audio console. Tested and proven in literally thousands of installations around the world. the cool thing about designing a console in software is you can make everything context sensitive. You're no longer bound by a hardware button or a hardware knob or control. So you can design the front of it, the way that you'd want to use it. And when you push a button, operate a control, it operates in context to what you want right then, right there. You don't have to figure out menu items that you don't need. They're all specific. Now, in this console, the Crystal Clear, you've got all the things that you can do with a DSP-based, software-based console. Automatic mix minus. You have the ability to, for example, automatically set gain on guest microphones. Let's say you have a guest come in. You don't know if this guy is going to be loud or soft. You ask him to talk a little bit, you push a button, and it sets the gain range right there. It sets the preamp gain for that guest. You've got, as I mentioned, automatic talkback to codecs, to hybrids, to remote broadcast. Maybe you got somebody coming in by who knows what, satellite, and they're on a dial-up remote for their IFB. Automatically handles that. So many automatic things that under the hood are complex, but for the operator, they're so easy to do. Of course, built-in on-screen clock, built-in different scenes or presets that you can bring up. Maybe you've got a show that is heavy on music or heavy on automation, or another show that's heavy on using the microphones in the studio, and you only need one or two faders for automation controls and audio. So you've got those choices to bring up different presets. It's networked, so you can put the console anywhere on the network as the mix engine. So that makes it really easy and convenient. If you have to move studios, you can just assign a different unit to control that mix engine. Or if you need to, you can pick that PC. It's the PC that's got the screen and the PC together. Just move that to another room, and boot it up there on the network, and bam, you're in control once again. Of course, the mix engine keeps mixing in case the PC is offline for a moment. So it just keeps doing the last thing that it was doing, so you're not off the air. There's a lot of other interesting features and benefits to this kind of console. And if you'd like to find out more about it, well, the director of virtual radio projects for Lavo is Mike Dosh, and he's done a video that's on the main product webpage for this. Go to Lavo, LAWO.com, and well, there it is right there. Click on the little thumbnail picture of Mike Dosh doing a demo at NAB, and you can see the benefits of using and installing this kind of audio console in your operation. You might find that really intriguing, interesting, and I think your operators will like it too. Thanks to Lavo.com for sponsoring This Week in Radio Tech. Appreciate it very much. All right, Chris Tobin, have you got a tip for our viewers and listeners?
Well, it's a simple tip. Since we were talking about internet-connected, Ethernet-connected transmitters and going from RF world and high-powered tubes to Ethernet connectivity and IP, recently this week, actually, I was working on a couple of projects, and it was coming handy. Was having a crossover cable, Ethernet crossover cable with my laptop, and a USB to serial adapter that worked out very well, and a couple of applications for telnet sessions and things of that sort. So I would say when you're traveling about, when you're with your laptop, or if it's an iPad with an adapter on it, make sure you have a crossover cable. This week alone, I used it at least 4 times, and thank goodness I didn't have to worry about using a switch or try to hook up with somebody to use a intermediary type device in order to talk to two computers. I just used a crossover and I was in and running. It was actually a TV transmitter it's a Harris TV transmitter, HD TV, and it has an Ethernet port. It was much easier using a crossover cable than trying to go through the switch that for some reason rejected connectivity from laptops that weren't part of the domain.
Good advice. One thing to have in your toolkit is a crossover cable. All right. Gary Liebisch, our guest from Nautel, can you provide us with a tip that engineers can maybe put to use this week?
I can, and it's going to be an analog tip instead of a digital tip.
Good deal.
I would like to encourage people to discover DIN connectors, DIN, particularly for low power transmitters like translators and everything up to a few kilowatts. We make our transmitters available at that power level with either 7/8, in some cases N connectors for the really low power stuff, but the 7/8 EIA that people have known to come and love for years competes with the 7/16 DIN connector. Now a 7/16 DIN It's not a fraction. It's not 7/16. It's not 7/16. It is measured in millimeters, and it's 7-16. And it's an indication of the diameter of a couple of the concentric contacts in one of these connectors. But the point is, these can be about half the price when you're trying to buy a mating connector for a piece of cable, and you find that these brass connectors are a couple of $100s. You can find DIN connectors that you can put on that same cable for about $70. DIN connectors are very popular in Europe, but they're just catching on over here. And we have a few customers that always buy their VS transmitters, for example, with DIN connectors. The other advantage to a DIN connector, in addition to being less expensive, is instead of having to take wrenches to it when you have to disconnect it in order to do service, it just has a spinning barrel like an end connector, and you spin that barrel and then you can disconnect it for service. So it's much easier to service as well. So but the next time you have to order a transmitter with at that power level, consider using a DIN connector. At our end, it makes no difference and no difference in cost. But I think in a lot of cases, you'll find them a lot more user-friendly than the typical 7/8" EIA.
That's a great tip.
DIN connectors have a better IM. They're a better passive intermodulation specifications. Cell companies are starting to use them more and more now for that reason.
That's right.
You know, Gary, I want to clarify for slow people like me. When you first said DIN connector, I thought you meant the little barrel connector that Radio Shack would sell, and it had all kinds of little pins in there. I'm thinking, oh, no, I don't want Gary to talk about something I got to solder little pins on. But no, you're talking about RF connectors that are of the DIN standard, DIN.
I think it's Deutsche Industrie Normand or something like that. It's a German electrical standard.
And you know, you're absolutely right. And I got to tell you, I probably a lot of people have the same trepidation that I do. I see a DIN connector and I think, oh, that's a European standard. That's not for me. I'm going to use an EIA flange because that's what I know about. So I'm really glad that you broke down the barrier just now for me understanding that there are advantages to this DIN connector. They are available. And, you know, it's probably something I should familiarize myself to. I'm going to put a link in our show notes to some explanation of DIN connector, whether it's Wikipedia or elsewhere, that show these things. And I like the lower cost because, man, prices on EIA flanges seem to have skyrocketed, and the fact that you don't need wrenches. Do you not need wrenches for even larger sizes, or just for the size you're talking about?
Well, you can use a wrench to tighten it, but you know it might not really be a wrench. It might even be just a pair of pliers. Just to tighten it down.
Cool. So we got crossover cable and DIN connector. All right, and if I had a tip, it's gone out of my head because I'm so excited about the DIN connector. I really need to investigate that. We'll put something in the show notes. Guys, we're out of time, and thank you so much, both of you, for participating. Chris, any update on the Pope parade?
Update: the Pope is in St. Patrick's Cathedral, and he's doing the services as we speak. I'm watching it on a CBS News feed right now, and he's doing his thing. And the helicopters are flying overhead. Henry Kissinger is in the audience, and it's going to be one of those nights. Motorcades are going back and forth in the neighborhood right now.
Hey, Chris, as we get closer to more into fall and into winter, It's going to get dark there. It already is dark there. You going to bring lights back out on your...
I'm going to bring the lights back out, yes. I was hoping I'd get past it tonight, but I was wrong.
That's okay. You look comfortable. You look good. Hey, Gary Liebisch, thank you for joining us from Columbus, Ohio. Appreciate you being here.
Yeah, Chris is on the eastern edge of the Eastern time zone, so his sun is setting. We're on the western edge of the Eastern time zone, so it's probably another hour here. Our sun is still shining, but you're certainly right about the coming fall. And I enjoyed it. I had a blast. This was great. The hour just flew by. Thank you, Kirk.
You're welcome to come back on, especially next time you got something to say or some technology to talk about. I sure appreciate you. Thanks to our sponsors, including Axia and the Axia Soft Surface, also Zipstream and the whole range now of audio encoders for internet with some fantastic capabilities, including adaptive bitrate streaming from either HLS or smooth streaming from Microsoft, and also to Lavo and the Lavo Crystal Clear audio console. Thanks to Suncast for producing our show this week on This Week in Radio Tech. Join us next week as we're going to be live at the WSB transmitter site, the AM site, 750 kilohertz, 50 kilowatts worth from Atlanta, Georgia. We'll see you next week on This Week in Radio Tech. Bye-bye, everybody.